Well, hello there and welcome to day 3 of the Building Apps for Windows Phone 8.1 Jumpstart. If you've been with us out there on the interwebs all the way through this, a hats off to you. We clearly have been here all the way through this. We're still here. Third day of this. Yeah. It's a lot of fun. We've been covering a lot of stuff. We are going to got a few sessions for you this morning just to round things off. We got one that has been bumped over from yesterday, the end of yesterday, because we got a little bit behind schedule. So today we're going to be running through a few sessions on tools, on the store, on building universal apps, and one specifically for Silverlight 8.1 developers.
Yep. So I guess we can do our beginning of the day introduction of each other.
Yeah, so first of all, I'm Andy Wigley. You've probably heard all this if you've seen any of the other days. I work out of the UK. I'm a technical evangelist. I've been specialising in mobile for a great many years, and hopefully you've seen me at conferences and the like.
And I am Matthias Shapiro. I am a program manager and technical evangelist here at Microsoft, and I've been working with XAML since forever, and I just generally try to connect devices to other devices, and that's kind of what I do for fun. So if you've missed what we've been doing for up till now, all these have been recorded. This is what we've been working on. Building apps for Windows Phone 8.1, we started with an intro, and then we had this kind of mini course where we ran through building a UI using the Windows Runtime flavor of XAML, which is the new XAML stack, the one that's converged from down from Windows. So we've now got a common XAML framework, and you can very easily build apps sharing a high percentage of your code. In fact, you showed an app yesterday that shared all of its code, apart from just like the package manifest was about the only thing that was different. So lots of convergence there. We looked at data storage, backup and roaming, and sharing files and data at the end of day 1. And then on day 2, we went on to talk about all sorts of interesting topics. Can you put me on to data? Yeah, sorry.
Thank you.
There you go.
Thank you very much. Yeah, so these are all Windows Runtime APIs that are available to Windows Phone 8.1 and also to Silverlight 8.1 developers. Loads of cool stuff, new background tasks, the maps and geofencing, loads of cool stuff around networking and authentication, web authentication broker, super story around tiles and notifications, cool new stuff in NFC and Bluetooth, the email with attachments module, otherwise known as contacts and appointments. Absolutely awesome video editing and camera stuff. We had a guest in, Matthias Hoekstra, who talked us through the enterprise story for Windows Phone 8.1. Awesome story there as well. And then we rounded up with a short session looking at how you could use SQLite. And that brings us to today, where we're going to be looking at some of the new tooling we've got. App packaging and submitting to the store, looking in a bit more depth at building universal apps, and finally specific topics aimed at our existing Silverlight app developer community and things they have to think about when retargeting Silverlight apps to Silverlight 8.1.
Okay, and that brings us to the big session for today, or the starting point. It's the big session because it's the one I'm doing, where we're going. It's tooling and diagnostics. So we're going to cover some of the new features we have available in the tooling, and some features that you might not have known were there, but are useful and helpful for building applications. We're going to have a little bit of a focus on universal apps, but we're also going to cover some more tooling specific to universal applications in our universal application session. So in this module, we're going to look at Visual Studio tooling, specifically some of the universal application project tooling. Some of the great XAML tooling that we have available. We're going to touch on Blend, and originally I had more of Blend because Blend is a fantastic tool, but unfortunately we've just got some time to deal with. Yeah. But we will show off a little bit of the cool web debugging that we have available. And then I'll do a lightning fast overview of the Windows Phone emulator. We've been looking at the emulator as we've been going along, so I'm going to touch on just the pieces that we've missed. And then I'll show the diagnostics and memory profiling tools we have available, and end up with just a couple fun debugging tips and tricks. So start with Visual Studio tooling for C#. The first big addition to Windows 8.1 or the Visual Studio update to RC, or if you're watching after we've gotten past RC, the update 2, is we have the universal application templates. This is 3 projects in a single solution: a Windows 8.1 project, a Windows Phone 8.1 project, and a shared project. And the shared project is really nothing more than a bunch of files that can get pulled into both of the other projects and then compiled alongside. There's a lot of cool stuff. We can switch code contexts inside of our application, inside of our files. And when we do switch the code context from a Windows Phone application to a Windows 8 application, the IntelliSense will warn us if we have a piece of code or a file that's living inside of our shared project. IntelliSense will warn us if that code is platform specific. So if we accidentally start writing any sort of code that only is going to work on Windows Phone or only works on Windows, IntelliSense will let you know, hey, this is a platform-specific piece of code. You're going to have to deal with that.
I had a giveaway there. Wasn't that the namespace on that slide snippet? Wasn't it Windows.phone.ui? It's like,
right.
Okay,
Well,
maybe that's one for phone. Yeah.
But it'll also IntelliSense will also show us the information.
In case you missed that obvious clue.
Right.
Yeah.
Right. Or perhaps you're pulling a file in from another project.
Yeah. I mean, yeah.
Right.
I'm joking.
But yeah, so it's really easy to do that project context switching. You see, at the top of every file, you're going to have this context, and there's a little drop down, and you can point it to Windows Phone or the Windows application and say, hey, I'm in this context now. We have universal project targeting, and that's just a quick and easy way to start up our universal projects. You can click on the drop down menu and use that to just pick your startup project right there. Switch back and forth between Windows 8.1 and Windows Phone 8.1. This is enabled for all the store platforms, and it's enabled for if you have more than one app project in your solution. If you're just a crazy person and you want to launch both applications at the exact same time, there's actually a property in the solution where you can go in and you can do multiple startup solutions, and then when you hit F5, it's just going to, boom, run both applications at the exact same time. It's pretty cool. That's a bit of a lightning run, and we'll look at some of this in a demo. But there's also some great tooling around XAML that we have new. We have a split design. So if you're familiar with XAML and Visual Studio, we have a split design XAML view that allows you to take a look at. That allows you to take a look at your code as well as what your code is going to look like at runtime. There's a great control toolbox where you can drag and drop controls from the toolbox right onto your XAML page. A document outline so you can see what the visual tree of your XAML application looks like, and then a properties pane with a great little search option so you can select a control and change the properties visually right there inside the IDE. XAML also has that view context switching. So you can have an application or have a screen that is targeted for Windows and for Windows Phone. And when you switch the context, it'll actually switch all of the context inside of the design view. And so what you see here is we've got a page, and on that page we have a date time or a date picker, and when we switch the context from Windows to Windows Phone, the date picker switches because it's a different looking control on Windows Phone as it is on Windows, and so we'll be able to see those differences shift right inside of our design pane without even running the application. We can also navigate our XAML using that little app, the little toolbar at the top of our XAML. In addition to doing the context switching, there are also options to view whatever element we have selected. We can look at this drop-down and view its entire parent history in the visual tree. And on the far right, you see we have a drop-down where we can view all of the set properties that we have on that control. So it's just a really quick and easy way to find out what context we're in, look at where our control exists inside of our XAML document, and then look at all the properties that we've set explicitly. We've also got some really great new XAML Intellisense available. We have Resource Intellisense, which shows all the available resources for a UI element. So all you need to do is you say my property equals and then see theme resource, or you could say static resource, and it'll pull up all of the resources that are available for whatever element you're trying to pick. I've been using this like crazy because it's extremely helpful, very, very useful. We also have Binding Intellisense. This will show all the properties available inside of the current data context, and all you have to do is do an open curly braces binding, hit space, and then all of your available properties are right there for you. The one trick with this is if you're binding to an object or view model, then you're going to want to set up your bindings objects as resources in your application, your app.xaml. So that would be going into your application resources, probably creating a new namespace, and then adding that object as a resource inside that app.xaml.
So that's if you're setting up your data context in code, you kind of got code that's getting an object, and just setting it in code, clearly that's not going to be of any help to you at runtime. So,
right.
So you've got to kind of figure out how you're going to.
Yeah, this is all about helping the XAML parser inside of Visual Studio understand where to go find all of those properties.
Because it needs to figure out, it needs to reflect on that object and find out what the properties are, so it can give you that list.
Yep. And then
it's helpful, really helpful if you.
Oh, it is. Yeah. it saves a lot of time. You don't. It's just great. Intellisense is great. Everybody loves to use Intellisense. It's nice to just kind of scroll through a list of properties and say, I want that one.
And the trouble with XAML is it's just text, isn't it? So if you were typing it in, you can get typos, and your binding's not working. So it's really helpful.
Yep. So the last part of that puzzle is to set the data context in your XAML. And so you set your binding objects as resources, data context in your XAML. And the great thing is that you can actually use the static resource IntelliSense to find that VM, or that view model. And then the last cool thing is we have this new right-click and go to definition. And so you can do this on resources or on bindings. If you do it on resources, it'll open the XAML where that resource is defined. If you do it on bindings, it's going to open the bound object class. And finally, XAML device pane, where we can change the display size of our device pane. We can change the axis and theme. You've probably been, if you watched us through this series, then you've watched us using this quite a deal, and you're going to see it again with the demo that's coming up here. Okay, so this is just a real simple little application. I'm going to run the Windows 8.1 version very, very quickly. Everything's very quickly. It's already installed in this machine. Yes. Okay. What this is doing is it's going and it's grabbing all the pictures in our pictures library, and it's going to show them up here. And it's inside a list view. We can scroll and we can click on one of them, and we can see that image nice and big. Head back and look at another image. It's just a great little image browser for our application, or for our desktop. So that's great. That's fun. But it's also a universal application, and this is one of those pure universal applications, which you're probably not going to see a lot of in real life, but it makes for a great demo. Where everything that you saw here, the view models, the view model, which is loading up all of our images, and the image view pane and the main page is just a two-page application back and forth with the back button, the software back button there. Everything here is living in the shared project, and so we saw that we had that working. And we can run it inside as a Windows Phone project. So let me do that using the tooling that I just showed you. And we're going to run that on our device. And switch over. Okay, here we go. Should be coming up any second here. Here we go. Okay. So here it comes on our device. And you see, I actually don't have a lot of pictures here. And the reason I don't have a lot of pictures here is because I'm pulling from the pictures library. And on a phone, we don't store most of our photos in the pictures library. We actually store most of our photos in the camera roll. So this is a great opportunity for us to use a tooling feature known as ifdefs, or compiler conditionals. And basically, simply, we do this hash if, and we can say, if we're using the Windows application, pull your pictures from your pictures library. And that's because that's where we're storing all of our pictures. If we have a tablet or if we have a desktop, we're much more likely to be storing all of our pictures in our pictures library. Whereas if we have a Windows Phone application, we're probably storing our pictures in our camera roll. So now if we run that application on the phone, it's going to pull pictures from our camera roll, and you see, okay, here's actually a pile of pictures that I have. So I can go into one of those pictures, and it looks like I've got an exception. It's a XAML parse exception. Where's that coming from? It's probably coming from our image view page because that's the only other XAML page in the application. What's happening there? What is happening is that we were using a software back button, and it's got a style navigation back button style. And if we switch our tooling over from our Windows application to our Windows Phone application, there we go. Okay, you can see this resource can't be resolved because it's not a resource that lives on Windows Phone. It only lives on Windows. And so we could actually apply this resource in the background. We could use a visual style manager to make all of this work nice and cleanly. But what we're going to do instead is just get rid of this button for now, and we're going to insert it in the background or in our code behind here. And so here you see, I'm going to switch back to our Windows context, and you see I've got all of my code highlights or colors appropriately, and I'm just creating that button in the code behind. I'm adding the command, the go back command, and I'm adding the appropriate resource, and then I add that button as a child to the container that was holding it, the Windows back button border container. So that'll run as a compiler conditional element if I'm running in Windows, and if I'm running in Windows Phone, I'm just going to make that element go away. So we're going to run that application again. We're going to pick another image, and now it runs, and I don't need a software back button because I have a hardware back button. So I press the hardware back button, and everything works exactly the way I want it to work. So I'm going to show XAML Intellisense so you can see it working, but I am running the clock real tight, and I want to get to diagnostics because that's really important. So you can see we've got a set of we've got some resources that we're using for item template. If we do static resource and we hit space, we can just select those. And the same thing with the bindings, because this page is bound to my data context, and my data context is defined in my app.xaml. I can just say, okay, well, inside the data context, I have a selected image property. I've got some image files. I've got some images. So I'm just going to select that bound property. You've seen it working. You don't need any more convincing that it does work. So in the interest of time, we're going to jump back into our presentation and walk through the next bits. So I would love to show you Visual Studio Blend. I wish we had time. We simply do not. It's a great tool. I very much encourage you to go in and take a look at it. It's got a great XAML. It's a great XAML design and visual editing tool. Now I know you're saying I've got a visual design tool in Visual Studio. Yes, but Blend is better. They're actually running largely on the same engine, but Blend has a couple great features that you might not know about. And it's got an animation builder. If you're putting together some animations inside of your XAML, Blend makes that really easy. It's got a control state editor, and we're going to look at that in the Universal project demo. You can create sample data really easily. It's really incredible. And you can also, if you're really on the design side of things, you can create these alignment guides for your application and say, well, everything needs to align just such a way. You define that in on one page, and you can export it and import it to other pages to make sure that all your pages fit the exact same alignment guides. We also have an IE debugger, which you can get to by going to debug down to the other debug targets and just open up the debug Windows Phone Internet Explorer, and then you can navigate to a website and debug that website using all of your IE F12 tools, the JavaScript console and the DOM Explorer. It's incredibly powerful. It's a great way to do website debugging for the phone. I wanted to show that. We don't have time. I am sorry. Rushing through the Windows Phone emulator. I can't even tell you how much stuff I cut for this. Windows Phone Emulator is a virtual machine, requires Hyper-V. It emulates screen resolutions and physical size. You've been seeing that, hopefully, if you've been watching us over the last 2 days. It allows this touch pass-through. If you have a touchscreen device, all the touches that you do on your device are going to pass through to the emulator. It can do multi-touch simulation, rotate emulation, and more tools. The two that I want to call out because we haven't looked at them is the Accelerometer tool. You can drag the red dot on that tool to change the accelerometer readings. It's a great way of emulating your accelerometer. And also we have sensor simulation, so we can toggle the sensor availability. And this is great if you're using gyroscope and you want to make sure that using gyroscope doesn't break your application on a phone that doesn't have it. Or NFC, if you're using NFC, making sure the appropriate things are being hidden or not being used. Location simulation is fantastic. You can change the accuracy of your location, create routes with geolocation, save and load geolocation sets, and you should go to session 12 to see more of that in action. Network simulation is also fantastic. Fast and slow networks, go to session 13, network and mobile services. SD card emulation, you can mount and eject SD cards and see how your application responds to that. Go to session 9, data storage and data roaming. Notification simulation. All right, notification simulation. We did a lot of this. We did notification simulation in the emulator in session 14, Tiles Notification Action Center. Go there to check out all the notifications.
And in session 3, watch Matthias scratch his nose.
Right. And then there's the Windows Phone Power Tools, which we haven't shown and we don't have time for, but it's essentially like your task manager, but it attaches to your emulator, and you can see the CPU usage, you can see the memory, and this isn't just for your application, this is for the whole device. So this is a great tool. You can just do a search for a quick search, either in Visual Studio, or you can even, it's a standalone application. You could just do a search for it on your device in general. So, diagnostics and memory profiling. We have a really incredible diagnostics tool for recording CPU usage, energy consumption, memory usage, and XAML and UI responsiveness. You just go down from the debug menu down to performance and diagnostics, and you can check those checkboxes. Some of them run exclusively, so you can't run CPU usage alongside memory usage. But you could run CPU usage alongside XAML UI responsiveness. And there's really no better way to do this, to talk about the diagnostics tool, than to just show it. So let's show it. Okay, we're gonna go ahead and just we're gonna pull that diagnostics up. Normally, if I had a good amount of time, what I'd do is I'd run the application, you'd be able to see how unresponsive it is, and then we'd run the diagnostics tool and check it again. But we're just gonna go ahead and jump straight into the diagnostics tool. You don't wanna hit play on your device to run these diagnostics. You want to scroll down here and hit start, and that'll attach the diagnostics session. You always want to be running diagnostics on an actual device and not on your emulator, because your emulator is not at all giving you a real world view of the sort of performance that you're going to want to be looking at and double checking. So I could start counting now. 1, 2, 3, but I think we probably get the idea already that this is not a particularly responsive application when it first starts up.
It's an underwhelming experience, that.
Right. So apparently it has something to do with photo filters. I can see that from the title. And it has a progress bar, so that's encouraging. But here, okay, now we've got you see, this looks dangerously similar to my last demo.
But it's even less performant.
But it's less performant. And so you can see this, our CPU utilization there. It goes up when we tap into an image. It's going to go up again when we run a filter. You see that filter is stuck, and so we've got some XAML responsiveness issues there. CPU usage goes up again. Okay, that's going to be good enough for now. We're going to stop our collection. And fortunately for us, this takes a lot of time too, so I'm just going to pull up a diagnostic session. It saves all these diagnostic sessions so you can go back and look at them later. I'm just going to pull up one that I've recorded previously. Here we can actually select just a portion of our application, our application session, and say, you know, it looks like this is where I had all of my trouble. So let's just grab that, and our CPU usage and XAML UI responsiveness is going to look at just that part. You can see it changing dynamically as I select these different chunks. So we're going to look at this part. The CPU usage looks at all of the methods that were called and that used up CPU time in this particular chunk of our application. And we can see that most of that was being used by external code. That's a normal thing to happen. That basically just means that the XAML framework was taking all those resources and trying to do some stuff with them.
It's stuff out of your hands. That.
Right. And so
but it could be you've given it stuff to kind of handle and process.
And that's exactly what we've got here. So we're going to take our XAML. We're going to look at our XAML UI responsiveness. You can see, okay, looks like most of the time was being taken up by this controls.group item, and we can drill down into this. Okay, we've got one group item there. Looks like an items control was taking up all that. It was an items presenter, and why was that? Oh, what is this? These are list box items, and this is the amount of time it took to render those list box items. Now, on that screen, we probably saw 12 to 15 items at a time. We got a little more than that here, and each one of them takes some time to load, and it looks like it was loading all of them. So
you've rendered a 3,000 item.
Right, I've actually
12 of them.
Yeah, I've rendered something like 160 images here.
All right.
And so let's. Fortunately for us, I know where the problem is, and the problem is in the fact.
You do surprise me.
Right. If I can remember where I put the problem, I think it's in the main page. The problem is in the fact that I have artificially disabled list virtualization. So let's actually go ahead and re-enable list virtualization. I find that most of my debugging problems are usually just Booleans that I forgot to switch from true to false. And we'll be able to see that if we run this application again. I don't have the diagnostics tool attached, but that doesn't matter.
You'll be able to see the perf.
We'll be able to see the perf difference.
Yeah.
That was substantially faster than it was before.
So because it's not having to take all your objects and figure out what groups to put them into and all that group sort of source
exact
group sorting, and you've immediately got a huge perf because you don't need groups in that. There's no group headers. So.
Right. Yeah. So and so it's instead of rendering every single item that I have, it just runs it just runs the ones that it needs to see, and virtualization is working appropriately. Okay. I wish I had more time. Oh goodness. But we're gonna do one more diagnostics. One more diagnostic session. It's in debug, and then we're gonna call it a day here on the diagnostics and tooling session. There is a great diagnostics session at Build at Build. I encourage you to go look that up because that is a substantially larger view of of the diagnostics and tooling. So the way diagnostics and tooling works is it's fairly simple. You take a snapshot of our application. Okay, now it says, okay, I've got a memory snapshot of your application right there. And we can open up a bunch of images. Oh, let me show you what I'm doing. Here we go. I'm opening up a bunch of images. And that one, and that's a nice little image. We'll run a filter on it. A couple more images. And you see that actually it looks like my memory is going up and down appropriately. So I probably have already fixed this problem. I'm just going to point out a couple of things. It looks like I don't have a lot of memory problems, so you're not going to be able to see the big differences that happen in between snapshot 1 and snapshot 2. Dang it. Let's. I'm going to pull up my memory leak, my previous memory leak diagnostic. Oh, it's disappointing. There's a red line that you saw before, and the red line was the memory cap limit that we have on the application. And so that it was an indication of if your memory goes above that limit, you can watch it in your diagnostic session. You can actually watch your memory hit the cap, and if you're running on a low-end device, you can redefine that red line to be low-end device, mid-range device, high-end device. When you take two snapshots, the way that you look at the differences of the snapshots is that you can see we've got a managed heap, and then we have a full heap. And the second snapshot basically says, okay, here's the difference. Here's the first snapshot is our baseline. The second snapshot says, this is the memory change in between the first snapshot and me. And you can take multiple, so you can take 3 or 4 or 5 snapshots and compare them to the different baselines. In this case, this was my artificial memory leak inside of the application. I just want to dig into this quickly so that we can see that we get a count difference when we clicked on that red 15, and the count difference shows us how many instances of all of our objects we have in between the first snapshot and the second snapshot. And so in this particular instance, we can see, okay, we've got a button that we might not have expected because in between that first snapshot and the second snapshot, we actually hadn't, there were no buttons on that page. But we can interrogate that button, and in this case, we're interrogating to find out why that button hadn't closed. And we can actually dig all the way down into things like, well, it hadn't closed because you had a window size changed event handler that was keeping an entirely separate page open that whole time. And if I hadn't fixed the demo before I came here, we'd be able to come in here and see that if we had kept this commented out, then we would have had an application where we're attaching an event handler, but we never deattach the event handler, and that just keeps the page alive, multiple instances of that page alive as we go through, and it keeps our memory profile nice and high. Makes for a good demo if you remember to keep it commented out. So the debugging tips and extras, just a couple of slides. This is in session 7. There's a debug toolbar that allows us to artificially suspend, resume, and shut down our application. But in some cases, the application is going to launch for another app. Well, we've got a way for you to debug that too. For share contracts, file pictures, or speech commands, you can right-click on your project, go into the debug tab, and select a start action where when you hit start, it doesn't launch, but it will start your code debugging as soon as your application starts up from another source. And then lastly, this is just fun. We added the option where to investigate your variables using a JSON Visualizer. So if you're pulling down data from your network and it's JSON data and you want to take a look at it with a nice clean JSON Visualizer, something that's a little easier to read, that's now one of your options. For more, there's a lot more at blogs.msdn.com/b/Visual Studio ALM/archive/ags/diagnostics. And they've just got a pile of blog posts and a lot of information on diagnostics. The diagnostics team has done a lot of work. So, a whirlwind tour of tooling and diagnostics, and there's a lot more out there. But I hope that gets you started. Hope it gets you using Visual Studio in an effective way, and diagnosing the memory problems, the energy problems, and the CPU and XAML UI responsiveness issues that you may have with your application. Up next,
Store. Yes. Well, so we're going to take a break, and we'll be back in a short while to take you through the app submission process and working with the store. See you soon. And welcome back. Okay, so this next session, I'm going to run you through the packaging of your app, the submission process, a bit about monetization, so we're talking about in-app purchase, the options for submitting your app. So I'm going to run you through all of that kind of stuff. In this module, we're going to look at the Windows Phone Store, the ways that apps are packaged and how you build those packages, how you test your package before submission, and your options for making money out of this app. So you've got different monetization options. And then we'll actually, at the end, we'll actually do an app submission so you can see what the process is and what it's like to work with that. So, okay, first of all, the Windows Phone Store. What is the store? First of all, the Windows Phone Store is a cloud service, if you like. It's the marketplace for your apps. It's run by Microsoft, and it is the only way that you can get apps onto public phones, like the general public's phones. As Matthias took us through yesterday with the enterprise session, enterprises can sideload apps for their own use, and they can register to be an enterprise publisher. But for regular apps that people are going to buy through their mobile operator billing, or through payment through credit card or PayPal or whatever payment mechanism, the only way you can get them on is through the store. So users buy their applications through that. You, of course, as a developer through Visual Studio, can unlock a device for testing. If you have a developer account, you can register up to 3 devices. If you have an ISV with a software department, you want to unlock more than that, you can just ask us, and through the dev portal, and we're usually pretty forgiving about giving you a few more than that. Students, and if you have registered for our App Studio, URL shown on the bottom of the slide, the App Studio is this web-based portal where a web-based tool you can go and create apps without needing any programming knowledge. With that, you can unlock 1 device for testing your apps on. So to be joining the store, to register, you go to dev.windowsphone.com or dev.windows.com. It's just one registration process, gets you into both stores. The charge at the moment is $90 a year for individual registrations. If you want to do the enterprise company registration, that's $99 a year. The company accounts have additional verification processes. So once you've got, one registration allows you to publish to both stores. If you're a student, if you haven't joined our DreamSpark program, why haven't you? It's free. If you're in full-time education, you can join DreamSpark for free, and that gives you access to all of our developer tools, the kind of professional editions of them. And that also gives you entry into our stores, registration into our stores. So that's all free for you if you're in full-time education. If you've got an MSDN subscription, certain MSDN subscriptions may also supply a registration token that you can use to register for nothing as well. So yeah, dev.windowsphone.com or dev.windows.com is where you go to do that. And we've really actually improved the whole experience for developers recently. A lot of stuff was announced at Build recently. one that's particularly exciting for a lot of developers is that previously, to register for the store, you had to have a credit card. We've removed that requirement. Now you can use PayPal to actually pay for your developer's registration. And we've got, names must have, new apps must reserve names now. So all names will be unique to make it easier for end users, customers to differentiate between apps. And of course, we've got the universal support for universal apps, so you can more easily create apps that target both Windows and Windows Phone. Certification is much faster. Apps and updates published at least twice as fast, sometimes within 1 hour. And we got much better detailed and more timely reporting. The actual policies that your apps must conform to in order to be accepted into the store, and we do obviously test apps when you submit them. That's now aligned, so they're the same for Windows and Windows Phone. And we've improved the way you can earn money. So we've improved ad SDKs for advertising in your app. For users as well, auto updates. So absolutely, if you submit an update into the store, users will now get those updates silently, so they don't actually have to go to the store tile and actually deliberately say install these updates. So that's an improved user experience. And we've got aligned app pricing tiers between the Windows and Windows Phone versions of your app. So we're bringing all that together to make it much easier to create one app. And in actual fact, we also, and I'll talk a little bit more about this later on, if you register a Windows app and a Windows Phone app with the same registered name, a name that you have reserved, they have a shared identity, which means that a user can purchase that app in one store, in the Windows Store for use on their PC or tablet, and they can automatically then install the phone version of that app for free. It gives them entitlement to both. So loads of enhancements. And actually, while you're on the phone, the actual end user experience when working with the store app has been hugely improved. The store pano, as we call it, the panorama, now the user goes in there, gets a much better experience. They see featured apps first, then they get the quick links, and scrolling to the right, then they can get all the different categories to drill further down. And then there's a kind of curated list of apps based on your previous purchase history. We'll give you a list of apps on there that we feel you might be interested in. And once you tap on an app to go in and find out about it, the initial view is much richer than it was before. You used to have to scroll to the right to look at the screenshots. It's all now on one page, so it's much easier to see the star ratings, the tile, and the quick look at the screenshots. And you get a short description. You can just tap on that read more to look at more. And you go over to the reviews, and you can choose how to sort the reviews, whether it's by more helpful or by star ratings, whatever works for you as an end user. Okay, so that's a bit about the store and how the store app. How do you package your apps up to actually get them ready for going into the store? We've got two different packaging formats. So Silverlight apps, they build into what we call a ZAP package. That's what we've always had. It's the same for Silverlight 8.1 apps as it always has been. And with Silverlight 8.1 apps, you've got both two manifests in there, WApp manifest and also a package.apex manifest. And I'll look a little bit more at when you use one and when you use the other in a moment. And that gives you access to all the Windows Phone 8.1 features. The Windows Phone Silverlight, the ZAP is everything. It's all your resources. It's your language references, your script, your language resources, all the images and everything. All gets into this fat pack, if you like. So whenever you ship an update with ZAP packages, the user has to download the whole thing again. Much better with Windows Runtime apps, the AppX packages. It's the same format that we use with Windows Store. And the AppX manifest is the single manifest that describes the app and all the capabilities and every requirements. Versioning is enforced, so whenever you submit an update to the store will update the versioning for you. You get incremental updates. This is a real plus with AppX packaging. So if you do an update, it will look at the package and say, oh, okay, that DLL's changed, that file has changed. And when a user installs the update, they only actually have to download and install those parts of it. And that's all handled for you transparently as the developer. You don't have to do anything to get that benefit. And this bundling also, which I'll talk about, which means that different language resources and language specific or scale specific images are packaged into separate little downloadable bits. And again, you get all that for free. You don't really have to do very much as a developer to get that benefit. So when a user installs your app, they just get the scaled resources that's appropriate for their phone and for their language. And if they switch to a different phone or different language later on, then it will automatically download just the extra bits it needs to keep running. Both installation to SD card. Apex packages are not encrypted, so you'll need to use obfuscation if you are concerned about your the package falling into the wrong hands and people being able to steal your IP. Zap packages are encrypted in transit. Right, let's look at the app manifest. We've got two of these, as I've called out. The app manifest describes your app, describes the name that it shows in the programs list, and it also has links to your images and logos and lists the capabilities. There's additional things in the AppX manifest, which is the WinRT apps. So you also have to include some stuff. The badge logo, splash screen is also in there as well. Oh, actually, SD card installation is shown as being AppX manifest specific on there. That's not actually true. I'm sorry for that error. That's actually both Silverlight and WinRT. So drill down into them a little bit more detail. The app information bit of it, the display name is what's displayed in the programs list on the phone. And then you also have this navigation page and entry point. This is the highlighted blue bits. You're looking at the images on the right there. For Windows Runtime apps, that actually just indicates an object, a class object that you're going to go to navigate to when the app launches. And in actual fact, sorry, WinRT, let's get this right. WinRT, the entry point is the app class, because in the app class, in your onLaunch method, that's where the code you have in there, actually the frame navigates to your initial start page. The one at the top there, the Silverlight one, it's a bit different. The navigation page there actually is the initial XAML page, because in your app.xaml.cs in a Silverlight app, there's no explicit navigation to a page, so that's defined here. And you have to list all your visual assets in here. So you've got your app icon and tile, and there's different tabs. But essentially, both manifests. This information is recorded in different places, but it's still recorded through the app manifest. So in Windows Runtime apps, WinRT apps, you actually have a whole tab for this, which is the Visual Assets tab. Windows Runtime apps, you have to define a splash screen as well. So that's all called out for you. And if you don't specify it, you'll get a big X, the warning that you haven't supplied all the required information when you go into the manifest editor. And the bundling, when you build the package, it won't work. So you have to define that. For Silverlight apps, there's nothing in the manifest about the splash screen. If you want one in a Silverlight app and you don't have to have it, you have to have a file called splashscreen.jpg actually in the root of your project, and then it will be used as a splash screen. And also the splash screen, you can supply different versions for the different screen resolutions for WXGA, WVGA and 720p. If you've got a 1080p phone, that uses the 720p version. So this is a little bit more drill down into the visual assets you need for a Windows Runtime app. We'll see this in the manifest editor in a minute, but you can actually supply assets, the artwork, at what we call different scale factors. Now, we touched on this on the first day of the Jumpstart. You can supply assets at 100%, a 1.4 scale factor, and 2.4 scale factor. In fact, what you need to do is, at least, if you're only going to supply one, supply the 240% dimensions ones. Actually, in fact, with Windows Phone, there are no Windows Phone devices out there at the moment that are at a 100% scale factor. Just to remind you, if you're wondering what I'm talking about with scale factors, this is the scale factor. Actually, it relates to the physical size of the device. Scaling factor. It's a calculation it's a complicated calculation figure that looks at the actual resolution of the device and the physical size of the device and the viewing distance. But essentially, all you need to know is that the scale factor that gets applied is kind of roughly aligns to the physical size of the device. So essentially, what you're doing, if you're supplying scale 240 dimensions, which are the biggest physical size images, then just supply those, and if it runs, the app is running on a lower resolution phone, then the system will automatically scale those down for you. So you're going to get a really good quality images on all different screen resolutions. So do the 240% ones. Don't actually, whatever you do, create 100% dimensions and then go into Paint or Paint.net and simply blow them up, because you're just going to end up with poor quality, high-res images. Start the other way. Create your high-res ones, and then if you really want to supply different images for the lower scale factors, you can, and you can specify them in the manifest editor. But in all honesty, there's not going to be many cases where you're going to want to do that. Just supply the 240% scaled images. For Silverlight apps, much simpler. We've got a smaller list of assets you have to supply, and the size you can see there on the right. The splash screen is in the manifest, 480. Well, it's not in the manifest. Sorry, I said this before. You have to put this as an image into the root of your application called splashscreen.jpg. You can actually supply a number of different ones if you want to supply high resolution splash screens for the the 720p, the 1080p phones out there. Go to the URI that's on the bottom of the slide there if you want to find out a bit more about how to do that. The next section in the manifest is all about the capabilities, and this is just your app declaring, I need to access some of these kind of resources. And all this is really, well, it's enforced through the APIs. If you kind of call an API that requires the capability to be declared, you'll get an unauthorized use exception will be thrown when you hopefully pick this up at app development time, even while you're debugging. So you need to declare the capabilities that you require to use certain APIs. You're much smaller list for WinRT apps than it is for Silverlight apps, and as you can see, the WinRT ones are nicely readable ones. If you drill down into the, actually open the manifest up in the XML editor, you'll see that actually the WinRT ones use similar kind of ID cap things as the Silverlight ones do. How this affects things at the point of sale is the user will see, when they come to install your app, you get that pop-up that says this app requires access to your network, to your personal data, to your best friends list, and will send you unsolicited emails. No, it doesn't do that. I'm joking. But this is this thing saying, do you agree to your app doing all these things? And of course, everybody just says, yeah, of course I'm cool with that. But it's still part of the user giving permission for your app to actually access these resources. And if they look at that list of things it wants and you think, well, that's kind of a bit weird for what I thought was a simple calculator app, that might be a good reason for them not to install it. So don't check all of these, just check the ones you need. The next bit of the manifest is your hardware requirements. Now this is hardware that the app absolutely requires to be on the app in order for it to function. So this isn't hardware that it could use, you've coded it up to say, oh, okay, if we've got such and such a piece of hardware, a front-facing camera, and then you light up some additional capabilities in your app and you show to the user something in the UI that while they're using your app says, oh, you could use a front-facing camera for this, would you like to do it? That's different. This is where the app absolutely needs a front-facing camera, otherwise it doesn't even work. So if you check one of these, then at the point of when the user is browsing the store, if you've got they've got a phone and they're using the store app and it hasn't got a front-facing camera, they won't see any apps which have got that front-facing camera hardware requirement checked. So this is how you limit it to really only the ones that you stop it getting installed onto phones where it won't run. Then there's a bit more information all about the packaging information. A lot of this is mainly referenced to the developer, but there is versioning in there as well, which for WinRT apps is absolutely enforced. For Silverlight apps, not so much. It's under the control of the developer, but you have to make sure that whenever you release an update, the version goes up. So a bit more under your control as a Silverlight thing. This little thing at the bottom is interesting. This look at the bottom line of the image, which would be quite small for you if you're potentially. But what it says is on the WinRT one for Windows Runtime apps, it says generate app bundle, and then there's a drop down. It currently says if needed. Most of the time, leave it as if needed, What that means is this is enabling this clever stuff that it looks at all the things that you have defined for your app, like different language resources, different scale specific images if you've got that, maybe language specific images, or and it actually divides them all up into separate little bundles. And this does it all for you. You don't have to actually, all you have to do is select this option. So most of the time have that. One of the other options is don't do this, which means you just get a fat pack like you do with a Silverlight's app, or and I forget what the other one is. But you, if needed, is going to be the one that you're going to want. And this gives you all these fast update benefits and the ability to just have resources. The technology behind that for resources is this thing called MRT, Modern Resource Technology. This is for Windows Runtime apps only. This is how the MRT determines the correct language resources and the image assets for the platform and device settings. So it looks at the point that the app is downloaded, the user's purchased it, and then this MRT kicks in and it looks at what the phone is that it's going to be installed on, and it only sends up the bits of the bundles that that end device only needs. So it's clever stuff, and it all comes for free as you're a developer, for you as a developer. So that was a lot of slides. It's much easier to look at in a demo. So let me just get back into my machine. After 2 days of this, I nearly forgot my password there. It's been a long haul. Okay, here we go. I've got a simple little solution here with our old friend, the Contoso Cookbook. Yay! 2 versions of it. A Windows Phone 8.1 version and a Windows Phone Silverlight 8.1 version. There you go. So just because we can. So let's have a look at the WinRT app version of the package of the app manifest here. So this is, let's get all the tabs in a line. These are the different tabs: visual assets, requirements, capabilities, declarations, content URIs, and packaging. The first one is the application. This is the name that will be shown in the programs list, and in the localization session, which was session 8. I talked about how you can localize this as well, so check out the localization session. So this is at the moment is just a string called Contoso Cookbook Simple. So that's the name that will be shown in the programs list. That's the entry point, which is the app class. I can think of very few reasons why you'd ever want to change that. The description doesn't get used so much. Then we've got, you can actually set which rotations, if the app only supports specific rotations. This is where you can check or uncheck whether if you are happy for it to be installed on the SD card, or for some reason you don't want to. Then we've got whether your app supports toasts or not. Lock screen notifications. This is where you can have icons on there. And then they've got a bit of tile update schedules. Moving across, this is the visual assets. This is where you supply the artwork. So this is the, you can see there's all these different sizes of tiles, and these have all been, are all linked to different images over here in your assets folder. So here we've got the different logo scale. You see that we just got the default artwork in this one. And you can go off, and if you want to supply artwork at any different scales, you can, but this is the one, the 240 one, you probably want to set. You can go off and find a different one. You go off into your assets and select the particular image that you want to use, which is logo scale 240 is what we're already using, so I'm not going to override that. The badge logo and the splash screen, which is this big 1152 by 1920 image. The splash screen, you also want to make sure, usually what that splash screen is usually your image is actually on a default light grey background. So if you're using, your image has got a background color, you want to set the same color in there, which you can set using a color name, or you can use a hash and then an RGB hex code for the color. And of course, going across, there's obviously loads and loads of other stuff on here. I'm not going to. There's the actual hardware requirements that you have to have. Here's the capabilities list where you check things that it actually has to use in terms of the capabilities. Declarations, this is where you have all of your background tasks declared, your file open picker provider, file safe picker provider. If you are handling file type associations or protocol associations, we talked a little bit about that in the sharing module, which was module 10, and then share target and update task. Content URIs is a whitelist. This is if you're if you're using a web browser control and you're calling out from JavaScript and into C# code. And then finally the packaging, where we've got the publisher display name, the family name, and this is where the generate app bundle is, always or never. Yeah, and then the other one well, we've got the WM app manifest, which is our Silverlight one, which is a little bit smaller. This is where we have our app icon, which is what kind of tile is the main tile. Support for large tiles, and then tile images. Again, we go off and you can go off and go and pick the particular image that you want to select for that, which is off down some assets in your project. We also got the navigation page, which is your initial start page, capabilities, long list, hardware requirements, and packaging. So somewhat similar to the other one. This is where the prevent deployment to SD cards has ended up in Windows Phone 8.4 for Windows Phone 8.1 projects. And you can also disable automatic backup restore of your app's files up to the cloud every night. This is where the language stuff goes. There is another manifest, of course, in a Silverlight 8.1, which is kind of similar to the WinRT manifest, but is kind of a subset of it. And this is for where you're using any Windows Runtime 8.1 APIs that need to have stuff defined in the manifest. So it's a subset for those things. I mean, the obvious one to pick out is the declarations, which is, again, you can do your background tasks. Much shorter list, but that's appropriate for Silverlight 8.1 application. That's a quick look at the manifest. Now, what about some other features? This is quite nice. Single instance store. So this is handled for you by the store. Again, it comes for free for the developer and the end user. But where they install something which is using some common runtime, so think of a Unity, for example, a Unity framework. So you quite likely have one or more apps installed on a phone that uses Unity. Now, rather than install the kind of common DLLs that the Unity framework ships with an app over and over, so you've got multiple copies taking up unnecessary space, the store will automatically identify that. So whenever you submit a package up to the store, it will figure out what the DLLs are in it, and it will identify these. And whenever you install an app, the end user purchases an app and installs it, the store knows, that Unity, they've already got that version of Unity installed up on the phone. I'm not going to ship these bits of it. So they just get the other bits. So that's real nice as well. The application storage and SD, I've already talked about this. This is available to both. Obviously, it's an end user feature. They can choose, if they put an SD card in, they can choose to install apps onto it. And they can move apps between the SD card and their phone storage. As you saw in the manifest demo there, you as the developer can prevent that happening if for whatever reason maybe you've got performance-specific reasons why you don't trust the speed of an SD card. It tends to be slower storage than phone storage. So maybe you've got some reasons you've tested it and finding some failures on SD card. You can check that to prevent the user from installing that app onto the SD card. Oh yeah, whenever an app goes onto the SD card, you needn't worry about security, because the app and all its storage area, everything to do with it goes on the SD card, but it is encrypted. So, and that can sit alongside the user's, music files or their photographs that they might also store on the SD card. Just the app storage area, the app package, the app little sandbox is encrypted. So, a bit of a summary here. I'm not going to go through every one of these features. This is kind of summary of what I've just been saying. So I'll leave you for this to look at when you get the decks, and it's a summary of all those features that I was just talking about. All right, how do you build a package then in order to get this up to the store? So you need to build an app package, and the way you do that is through Visual Studio, of course. For Windows Runtime apps, WinRT apps, if you right-click on the project, there's a Store sub-menu on the context menu there, and you go Store, Create App Packages, and a little wizard comes up. It asks you some questions. It's very, very simple. You can actually normally allow the store thing to automatically increment it. It kind of takes care of things for you for the version, but you can, if you really feel strongly about it, you can override that and set it manually. There's the generate app bundle thing again. And then the packages to create. Normally you just check neutral unless you're using some native dependencies in there. Classical example of that is if you're using SQLite, then you would, instead of the neutral one, you probably would check x86 and ARM instead. So you generate different packages for the different targets. In actual fact, Windows Phone, I believe at the moment every phone out there is ARM, but that could change. We could have x86. So just build both packages. It's done for you automatically, and that will build the packages ready to be uploaded to the store. For Windows Phone Silverlight apps, there's no specific menu option to build an app package. Every time you build, it creates a zap for you. And a zap is just another name for a zip. If you take a zap file, rename it to .zip, you can just open it with your favorite unzip application. You can open it in Windows Explorer and have a look at what's in it. And that's just created automatically. When you create a package for submission up to the store, you just have to remember to select the release build rather than the debug build. So we built our packages. Now you could just submit them up to the store at this point, and they will test it for you. And if you're lucky, it will pass the certification testing, and it will end up in the store. But we can actually do some of that automated testing that they do yourself before you do submit it. So for Windows Phone Silverlight apps, the way you run .whack, as we call it, is you, again from the store, you right-click on your Silverlight project. There is a store menu on there, but the only option on that store menu for this kind of project is Launch Windows App Certification Kit. And that runs a various number of tests for you and shows what it is. And I'll show you a demo of this in a minute. For Windows Runtime apps, when you create the app package, then you get the option to run the whack test as the end of creating the app package. You can actually run up the certification kit manually as well, and again I'll show you. And that will run tests. There's lots of different validation that you can perform. You select the appropriate option and it will run through loads of different tests. And this actually is the automated testing that Microsoft does itself when you submit your app up to the store. So it will just avoid that delay of letting them do the testing, and then they'll come back and say, oh, you didn't replace any of the default images, that's a classical case, that are in the assets folder. You know, all these tile images, you just had the stock ones that were still in from Visual Studio when you didn't create new project. You've got to change all that, and that's one of the things they test, amongst a lot of other things. So, show you that. So let me open my next little solution. Which looks spookily like the previous one. It's still the Contoso Cookbook Simple, and we're going to do the first of all the Windows WinRT app. Right-click on the project, Store, Create App Packages. So this is how you build your app packages. First of all, it's telling you, do you want to build packages to upload to the Windows Phone Store? Yes or no. I can't imagine what you want to do. No, that's what we just asked it to do. Let's just try. So if you say yes, it's going to go off to the Windows Phone Store. It'll make you sign in with your Microsoft account. And then you're getting into sort of the option, so you're talking to the store at the background. So actually I just want to do the testing at this stage, so we can go through this. You're going to build the package without going off to the store and all this reserving app name stuff. We'll do that later on. This is the automatic, you can automatically increment, good idea, or you can, if you really object, you can say that. And then this is where you change, neutral for any CPU out there is probably what you want for most apps, unless you've got some native components, in which case you would check probably those two. And then you can create the app packages, and it's just going to go off and build our packages. We've got a release build, and then there's the output location. I'm actually going to copy that. We're going to go to the app location. So we could launch the Windows App Certification Kit from here, but just to show that you can do it anywhere. I'm going to click on the output location. So this is the location where it has got that app package. I'm just going to copy that. And then just to show how you can actually run that anytime, I'm going to go off to my start screen and go Windows App Certification Kit. And it's picked that one up. We're going to run it. And these are the different options. You can validate a Windows Store app, a phone app, a desktop app, or a desktop device app. We're going to do a phone app. This is where we're going to go off to find the file. So we can actually navigate to where it is, which is here, and go down to my current demos. Which is this guy, and we're into this, and this is the app we're just building. There's our app packages, and got one. This is the current version, and so we can say we've selected the Zap. Then we got all the tests that you need to run. So we can say yes, I want to run them, and it's now running the WAC against that. We're validating the app, and it's checking the artwork and capabilities and all sorts of other stuff. This is, again, like I said, is the certification testing that they do. And that should take just a few seconds to run. And in a minute we'll get the report, and then we can have a look at what it's doing. While that is going, actually, just let me go back to Visual Studio, and what I'll do is show you how to launch the other one. I'm not going to go ahead and do it, but you can actually obviously do that one. We've got to build it. Okay, yeah, build that project, and we'll go back to the WAC that's running in the background in a moment. So that's built. And then we can go store, launch Windows, and again we're running the WAC, but this time against. It says, I can't do this two things at the same time. So that's the other way of launching it. So this is right. We're back with the one that I set off before against the Windows Runtime app, and we're analysing the results, creating the report, saving the report, and in a minute we'll be able to have a look at what it says. How long does it take to save a report? Come on. It must be saving a very, very detailed report in a place a very, very long way away or something. This is time to go and get a cup of coffee, plan the rest of your day. Right, well, I'm not sure I want to wait forever for this. Well, maybe we'll come back to see whether that's finished later on, because I want to keep moving on this session. When we come back to the next demo, we'll kind of have a quick look at the report. I will tell you up front that what it does is it finds that there's some branding errors in there. So it's detected some default artwork that we haven't actually updated. So we'll have a look at that when we come back, if it's finished. Otherwise, I'll just kill it. All right, so that's the testing thing. How do you make money out of your app? This, after all, well, your objective may be to inform and excite and all the rest of it, and that's absolutely a good thing to do as well. Or maybe you're building apps for a corporation as a branding thing, or extending services out, whatever. But if you want to sell apps and make money, you will want to know about that. So for paid apps, when you submit your app into the store, you can select what price you want your app to be sold at, which could be zero, could be a free app. Completely free to use without restriction. Another monetization is you give away the app for free, but you have ads in it, so you earn income through ad supporting. So you get a small amount of money from every time anybody sees an ad, or if they click through an ad, you get more as well. You might choose to ship your app, sell your app for free, but then have additional capabilities inside it that the user can unlock through in-app purchases. Obviously, be careful of this. There's been a lot of justified bad publicity for children buying games on their dad's phone, or mom or dad's phone, and playing the game, and then there's all these they get to a certain level, and to play the next level you've got to purchase an in-app purchase, and people have been running up huge bills. So there's been a lot of justified focus on this kind of bill shock stuff. Actually, we've got a great feature on Windows Phone called Kids Corner that can prevent all of that sort of thing. So you can actually inactivate the Kids Corner feature and give your kid a list of apps that they're allowed to run, and they get their own start menu with just those apps visible on it, and it's locked through a pin that only you know, of course. So your kid can go and play away on those apps in Kids Corner, and they can't sort of do any in-app purchases or purchase additional apps. You can have, going back to the monetization options, you can have a paid app with a free trial. This is very popular. You allow people to try your app out for a period. And then the top of the one on the list there is the paid app, which obviously the user must purchase it at the point that they select it in order to download and install it. There are pricing tiers that start from 99 cents or equivalent in a local currency, going right up to quite a lot of money. You get 70% of the revenue goes to you as the developer, 30% cut goes to Microsoft. That is industry standard 30-70 split, which is the same as all the other smartphone platforms. So the trial API, this is where you can ship your app. It's a paid app, but they can install it for free for a period. So it's up to you. You decide how long the trial is for. So you can have a time-limited trial, or maybe it's a feature-limited trial. So you kind of allow them to use the app, but when they try and use a feature, they say, I'm sorry, this is not available in the trial edition. You need to purchase this in order to unlock this additional capability. And there's this current app object.license information. We've got a simulator you can use for obviously for testing this in debug. And you can just get that license information object at any point in your code and check the is active. Is active means this is a purchased edition of the app. Is trial means the user is currently running it under trial. And you can also, if you've set an expiration date, you can look at that expiration date so you can figure out how long they've been running it under trial. So that in that you make your decisions in your code on which features to allow them to use. In-app purchase is another great way of getting allowing your user to purchase additional functionality. There's two kinds, durables and consumables. And you can have your own payment provider if you don't want to use ours. So durables and consumables, these you register through the store. These aren't physical products. You can't sort of sell a pizza through this. These are virtual products, if you like, that you use to allow the user to unlock additional capabilities, to download additional content that they can use in the app. A durable is something that once they've purchased it, they own forever, like levels, additional levels in a game. And consumables is kind of tokens that they use up over time. So you give them, they purchase 100 tokens that as they use a feature, they spend a token. And when they're gone, they have to purchase more of them. There's this product licenses dictionary in the license information object where you use to check access to in-app purchases. You add in-app purchase products into the store through the Products tab, and the graphic shows you there. You tap on Add an in-app product, and they can go off, and you go in there and you give it a name and set the pricing, and they get sort of verified as well, and then they're available to use in your app. You submit it. The dialog you go through is pretty similar to submitting an app. So you set the properties and the description and define pricing for it. This is with the in-app product properties. You give it a name, you give it a unique identifier, you just say whether it's durable or a consumable, and then you can actually give it a time limit on a durable, or and then you actually give a content type, which is of use to the users. So they can figure out what it is they're purchasing, and then you pricing you can set and which markets that product is available in. There's loads more options as well you can select as to which store languages it's available in, you can use keywords to help categorize products in your app. This is what you select to help you find in-app products and help your code find the products that you present to the user in your code logic. The product detail you have to set for each language your app supports. So this is, I'm afraid, a fairly tedious exercise, but you need to do that so that you're giving the product, the in-app product title, an appropriate for the languages that your app supports. Then in your code, use this kind of the current app.requestProductPurchaseAsync method. Gets the details of in-app purchases that the user has purchased. So you can then decide at runtime which features to unlock and allow the user to go to that game level or whatever it is. I'm actually a little bit short on time, so let me just. I'm going to show you very quickly. I will show you the demo. I'm going to go for it. We're still saving the report, so I really am totally not interested in that. There we go. I can't even kill it. This is bad. Where did we go? I hope that's just going to run in the background and not going to upset things. Fortunately, I run it outside of Visual Studio, so I can ignore and pretend that's not happening. Oops. No, not that one. This guy. So this guy, I'm going to add a new button to the main page. It's our Contoso cookbook, yay! Let's add another button to it, to the main page. I'm going to go off to the document outline. I'm going to go to my app bar, command bar. Let's, I'll go to my primary commands. Let's add ourselves an app bar button, and the icon will be. I wonder if we've got one for purchase. How about buy? No. Let's see what kind of button should we have? Accept. Never mind. I'll find an appropriate button. We'll find an icon later. Let's call that buy, and oh no, save. That's right. Sorry. Remember the scenario here. So it allows you to save the a recipe to your local PC. This is the idea, and then I want to have a event handler on that guy. So let's go off and create ourselves a click event handler through that. And I've got a little snippet of code which is the in-app purchase example. So this is it's an awaitable. So I need to put async on here. Up bar button click and. This is where it finds out the list of in-app purchases. It finds the first product listing. It searches the list of products for a in-app purchase with a keyword of save recipe. Now I've already uploaded this to the store for this app, and then it looks. This is where you find out for the license information. Product licenses for the product ID of that in-app purchase item, and find out has the user purchased it. If they haven't purchased it, then we ask them to purchase it by calling this request product purchase async, and then they either purchase it. If they purchase it, we enable the can save capability. Otherwise, we say no, you can't. So we put a message up saying sorry, you're going to have to buy that. So let's try this on the phone. I've got this up here I've got a real device because it works better on a real device. That's just a little pin on the phone, which I'm going to change later on. It's not the one I use all the time. And let's go onto the device. And oh, hang on, I've got one little thing I have to fix up on here, which is using Windows UI.popups. There we go. Try it again. Bring up the app. This is running on the phone. In a minute. Trying to. Not running on the phone. Hello, Earth calling Visual Studio. Come in, Visual Studio. Oh, it's registering the application to run from layout. Waiting for a required operation to complete. Ah, don't tell me this whack thing is blocking us. I bet it is. Hey, you're going to have to get ready with the explosion. Yeah, yeah. Well, that would have shown you that you saw the code, and that's not going to work. And I'm going to kill Visual Studio, I think, see if we can get this to work. Visual Studio's not responding. Let's close Visual Studio. Yeah, just kill it. Go away. And see if we kill the whack. Close that. All right. So, which could make the next demo challenging. Right, what I'm going to do, of course, I've got the slides running on another machine, so what I'm going to do is just do a quick... Oh, that's... I like that one. I hadn't seen that. That's cool. Thank you so much. Yeah, yeah, I'm in trouble here, so let's go to the task manager, see if I can kill the whack that way. It really doesn't want to... doesn't want to go. Where's the whack? There we go. Please go away. Thank you so much. Okay. Right. Because I'm a glutton for punishment, I will try this once more, because actually it won't take long to demo when it actually runs. Let's run it on the device. Bring up the display again. Hey, there we go. Thank you. It was the whack was killing everything. So I've now got a save option, and this is the... should go off to the store at this point, and nothing's worked. Oh yes, there we go. Confirm purchase. So it's gone off to the store. This is a real. I put this up as a beta app. I submitted it into the store. So it's here we go. It's saying you can choose to download this in-app purchase, which is free. So hey, yes, let's download this in-app purchase object into it. And so oh okay. Inquiring minds may find this error code helpful. All right, and maybe that's something to do with running as a beta. But anyway, you got the idea. So actually in cancel, we come back, and then we're back into our app and says purchase required. So that was an interesting experience on a lot of levels. Okay. You can add support. You can have ad support in there. There's a number of different ads. We have one. Microsoft Pub Center is excellent, but there are a number of other ones as well. We don't require you to use ours. Right, finally, how do you actually submit up to the portal? So you have to, first of all, just think about this shared identity apps. Now, one of the things I'm going to show you in a minute is you reserve app names, and they must be unique. When you reserve an app name through the Dev Center, that's yours for up to a year. If you don't submit an app using that name within a year, you lose that usage of that name. Now, once you've reserved a name, at the point that we actually submit the app up for into the store, you choose that reserved name, and that ties it to that particular application. If you then submit, like you say that you've just submitted the Windows app, and if you then submit the Windows Phone app and choose the same reserved names, they're linked together forever. In fact, you can't actually undo it once it's done. They're considered to have the same identity. You'll just see this thing, a thing called a PFN. If they have the same PFN, that's a package family name. Essentially, that's when you reserve an app name. That creates a PFN. And so when you assign your Windows app and your Windows Phone app to the same reserved name, they end up having the shared PFN. This means that they have a shared identity. What that means for the end user is that in the store, they see against the app this little Windows Phone overlaid over a Windows icon shown on the top there. And if you look carefully on the store, you see the app. It says free, and then you see that little icon for Quiz Bowl. That means that if they purchase the app on one for free, they get automatic entitlement to the app on the other platform as well. They have to go and install it, but they don't have to pay any money. This is a bad example because it's free anyway. But if it actually was a paid app, they pay for it just once, and then they can install it for free on the other platform. Regardless of because you could actually submit to the store different prices for the Windows app and the phone app. But if they buy it at the cheaper price on the one store, they get it for free on the other. So actually, there's no point in having different prices. But that enables all this goodness that we've talked about, like you get this roaming data, roaming settings. So they use the app on one device and they change their background color, and it automatically pops up on the other device with the same background color. And you get the same push notification IDs, and the push notifications go to both and that sort of thing. Load of goodness that comes out of this. And they get access to in-app purchase durables as well. So you reserve your name You can do this from Visual Studio, and after you reserve your name, you later on will submit your app. So reserving a name is an early part of the process. You clearly cannot reserve a name that somebody else has got, like that trivial example of Facebook. Oh, who would have that name?
I've never heard of it.
But if you have that, and if your name is available, you can then associate your Windows Phone app also with the Windows app as well, if you wish. You don't have to do that. You do that with this store associated app with the store, and this brings up this wizard where you can select one of the names an existing one that you've already reserved. So you know, if you end up building an app and you reserved a name and then you throw it away because it's rubbish, and you start a whole new project and you build it up and you go into store associate app with the store, you can select the same name you've already reserved before, because it's like you're starting over. Or you can create a new one, reserve a new one, like with the just entering one at the bottom there. It is a manual process for Silverlight 8.1 apps, which I will show you. Then you select your pricing, you select which markets it goes to. There are stricter content policies for China, so just be aware of that. There are game ratings for games that you have to enter. Then you've got your distribution channels. Does it go to the public store when it's passed through certification? Is it hidden? It goes into the public store but doesn't turn up in any of the listings. So it's one little way of having private apps, because you know the link to that app in the store. Or beta, as we say in the UK, or beta, as you say over here. So that means that you just put the Microsoft email addresses of a Microsoft account, like a Hotmail or Outlook.com or something, and they can install the app for a period of testing. It never expires, so you can have apps that stay in beta forever. But beta apps you can't then sort of bump them up to go into the public store. So you'd actually then have to go through a new submission process. Beta apps don't go through the full testing that public ones do. And then you can publish it, and if it's a Silverlight app using MPNS, you can put a push notification certificate in there, and your games rating certificates. And then you choose the app to upload, and you kind of saw a bit of that already. Then you can upload multiple packages for each supported OS version. You upload it to the store. You enter loads of information for each of the languages and images for each of the languages that you are supporting, which can be a tedious exercise, but it has to be done. Promotional images you submit as well, which go onto the store apps where people are browsing on the web, the store, or in the store app on the phone, so they see some of these promotional images. So if your app is picked for being one of a featured app in the store, then they'll use this big background image that you supply and some of the bigger icons. So it's important to take the trouble to supply all this promotional stuff. You need to supply some legal URLs and privacy URLs and a support email address. So you have to specify these kind of things. And then when you also got this technical exceptions, if you've got a username and password that needs to be submitted, then in order for the testers to test your app, you can add it in the certification notes. Quick little demo of showing the process of this. This is the last and greatest version of the Contoso cookbook. This is the one. This is the one we're going to go for. So I'm going to go to store, associate app with the store. Have we created the app packages? Create some. Oh, all right. That wasn't quite what I was expecting. Just let me consult my notes for a second. Okay, wow, I need to go to Windows Phone Dev Center, it says here. Okay. Oh, that's because I already submitted it. So Windows Phone Dev Center, this is the Dev Center. This is my Dev Center, actually. And we can go to Submit an App. So first of all, you need to enter some information. So we go into app info. So this is the first page. So we're going to give it an alias, and we can you can reserve the name here, or we can pick one that we've already got before. Let's take the Jumpstart Demo 001. We can associate our app with it. This is so now we've associated our app with that name. You give it a category, so we're going to go for health and fitness and diet and nutrition, And then we can say, do we want any pricing? No, actually, I'm happy for this to be free. So there's no point in having free trials. We're going to send this to all markets. And when we're happy with that, we can say, yeah, we're good with that. And go to more options. You can say to the public store, or we can say, oh, no, I'm going to go on the beta. And if you want to do that, then we can put some email addresses in here. Oh, I'm on a US keyboard here. Oh my goodness, what is it? Oh, yeah.
Are you looking for the hash again?
Yeah.
It's right above the enter key.
No, ampersand.
Oh, the ampersand.
Yeah.
How? I was all ready to help.
Yeah. You know what? I think I might go to the public store. It'll fail anyway. Yeah, there we go. Okay, and we'll publish manually. It won't actually. There are problems in it actually, so it won't complete. So we won't end up with a rubbish app called Jumpstart Demo 01 in the store. So that's the first step, and in a minute it's going to ask us to upload the actual app package that we've got. So we need to now go and tell it, okay, that's the app info. Where is the package? So we're going to go and find our app package. So we go off to where I previously built it, which is, I've got a link up here somewhere. Here we go. God, how many demos? There's so many. App packages, and then we got 1 to 0. So here's our app upload, and it's going to upload the file. So this is where we've got our built output that we built before, and we're going to then you go off to when that's saved, we move on to the next stage where we enter some more details like the description and the description of the update. Here we go. So we've got our version. We'll let the system do that. Then we've got to put a description for the store. It's an awesome app. And description of update. Well, that's optional, so we don't need to do that. Keywords. Help people find your app. Recipes. Food. You know, whatever. So you can add some. This helps people when they're doing a random search. Then you've got to supply some images. So again, we've got to go off to supply some artwork. So we go off to here, to our project, which is over here, over to here. Oh, hang on, let's go up, back. There it goes. App tile icon, and you see the process. And I'm gonna, you know, we do all this. We need to have a screenshot. You've got to have one. So we'll go off and, oh dear me. We should just go back to the same place. That would be really kind of helpful. And there we go. And there's a screenshot, and that's loaded in as well. So this is the bare minimum of the stuff that you have to supply, and then you save. And the next bit, you go off and sort of say which markets and enter a bit more description. And so it goes on, but I'm going to leave it at that. You get the idea about the process of submitting it. We're actually nearly there, so I think, optional stuff. Oh, actually, we're just going to review and submit, and we probably can submit that up for verification. Yeah, it looks like they're happy, they're good, so there's our app, and we can just, it seems to want some other information. Oh, we've got to edit some more stuff. So anyway, I'm going to leave it at that because I'm out of time, frankly. Interesting though that is. And that actually wraps up the store. So
I'm tired.
Yeah, just submitted an app in record time there. So I hope that led you through the process and you get a feel for what it's like to submit an app. It's, you know, you've got a fair amount of information, but remember, this is how your users decide whether your app is worth installing. So you need to spend a bit more time than the 5 minutes I spent on it there in order to really make sure that you've got the right screenshots and the good artwork and good description, and you're also supporting users in different locales if it's a multilingual app. All right, so we're going to take a break, and then we're going to have a deeper dive on universal apps with Matthias.
That'll be fun.
We'll see you soon.